Hi guys, today we are going to discuss about my calendar 2 problem on LeetCode. We'll discuss about the brute force solution and then we'll go to the optimal solution. So what does this problem say? Let's take a look once. We need to implement a program to use our calendar that is we are that what algo will design. We can add a new event if adding the event will not cause a triple booking. Okay, so at a max I can book in like once, like in a time frame. If I look right, I can book once on the same time frame, or in the overlapping time I can book twice. But what I can't do is I cannot book thrice if that time frame overlaps a bit. Okay, so that is what is meant by triple booking over here. Okay, so a triple booking happens when three events have some non-empty intersection, basically what we just draw. Okay, now let's see what is the my calendar 2. You have to initialize the object and you have to return true or false in your answer. Okay, cool, wonderful. So let's take an example and let's go by the brute force approach once. Okay, so I have just taken a small example to explain you the brute force approach. I didn't go with the test case because it would have been too big to draw over here. Okay, now we are having these slots basically in our test case, 1 3 1 5 and 2 2 3. So these are all the time. This is start time and this is the end time. Okay, similarly start time, end time, start, end. Okay, now thinking about the intuition over here, what we can do is like, hey, let me just take a array of size like whatever the maximum value of time over here end time will be, and the smallest value basically. So let's say smallest value, since time cannot be negative, you can start from 0 and you will have this data structure. Okay, so what I can do is like, if I want to see if something is overlapping, I'll just use frequency array sort of thing to get a basic idea for the brute force. Okay, so let's say from 1 to 3, if I say, hey, this interval is occupied, this interval is occupied, this interval is occupied. Now I say 1 to 5. Okay, so from 1 to 5 I need to update this interval. now this has been already used, so this will become 2, this will become 2, and this will also become 2, this will become 1, this will become 1. I just added because this is the second meeting that happened. This was an intersection. Okay, now I say, hey, let's add another meeting like from 2 to 3, but our question says triple booking. Okay, that is not allowed. So triple booking, like when your frequency goes to 3, it won't be allowed. As soon as I add over here 3, I know something is wrong because 3 is the limit that I cannot touch. Okay, so 2 was the max. If something is coming up, then A, it's not allowed. So I will just simply say I cannot add this. I'll return the false and I will not update this, and I'll leave it at 2. So this is one brute force approach where you will be filling up this, and as you are filling, you have to increment it. You have to again go from here to here, and as per every test case you have to find out if you are exceeding the limit or not. So this is not that much optimized. Okay, we'll talk about the optimized one now. So a better solution will be to use line sweep algorithm. It works by marking when booking start and when booking ends. So we mark the start point by incrementing the count and end by decrementing. We will be maintaining an ordered map. It's very necessary to maintain an order map. As we are finished with this example pseudo run, you will understand why we are trying to say ordered map, and you will also understand what is, the why are we doing this plus plus and this minus minus. You will understand that also at the end of this. And you also need, this is a generic algorithm. You can define the value, let's say max overlap booking. You can have that variable, say max overlap booking, mob, let's take that variable, So max overlap booking, I'll define over here as let's say we can say 2 in our case, because the bigger than this I won't allow you to book. I can also use, like, when interview changes your questions, like instead of let's allow triple booking, and I don't want to allow the fourth booking, so you will just change this variable and you are good to go in that case also. Okay, let's do a dry run and we'll understand how this algorithm works via the dry run in itself. Okay, we have the generic idea. Let me use this yellow pen to, okay, this is an area for our order map. As soon as I see an entry, I see 10 and 20. I am currently at this. Okay, I see nothing is here, so I put 10. Okay, and then I put 20, and since they were having nothing, I'll say start will be my 10 and end will be my 20. Okay, and start will be my 10. This start will be this. Okay, so I'll just increment the count in my hash map. Oh, and -1. That's it. It's simple. Now, to qualify whether this booking happens or not, I need to take the sum. So as per this algorithm, prefix sum of map will tell active bookings, and it will, by that sum you will be able to know at any given point are they overlapping or not. Okay, so we have to do sum one by one whatever the values are in this map, and at any given instant whenever your sum is greater than 2, you have to say, hey, I found that over booking. Okay, this is how this algorithm works. Okay, let's try to do one round of run and we will understand this. Okay, so for here I do 1 and then -1. This gives me 0. Okay, is my 0 greater than 2 MOB? No, it's not greater than 2. Okay, then this value is okay to book. I'll return true in this case, and this value can stay in my hash map. Okay, so I'm just letting it there because it's booked and it is occupying some data so that we can track it further. Now since this is done, I will try to move to this 50 and 60. I'll just add 50 and then I'll add 60 in my map, 1 and -1 as per this start and end, 1 -1. Okay, now I do need to take the sum. I'll just say, okay, let me take the sum. I start from here and I will end to here, so I get 1. Okay, then the next value -1. This will come to 0. Hey, is this greater than my MOB? No, this is not greater than my MOB. This is lesser than my MOB. So okay, that's cool. There is no issue at this point. Now to this 0 I add +1. These two values are done. I am at this value currently, so this gives me 1. Is this greater than my MOB? No. Then I go to the next value, this one. Is this I'll calculate it will is this 0 greater than my MOB? No, this is not greater. Okay, then this value also doesn't have any problem, it can stay. Okay, this value can stay. Let me clear it out. Okay, this value can stay. That's cool. This is staying. 10 and 40. Okay, cool. I get now value is 10 and 40. So whatever is 10, I just increment it. So this will become 2. So this becomes 2. Okay, and 40 will be between 20 and this. So 40, this will be -1. Now again, do the sum of these values one by one. Okay, so 2 -1, this gives you 1. Is it greater than my MOB? No. Then with 1 again I get a -1, this one. So okay, 0. Is it greater than my MOB? No. Then I go to this pointer, 0 plus 1, this is 1. Okay, not still greater. minus 1, this will 1 minus 1 will be your 0. No issues. I don't see any issue. It is not greater than my MOB. So I can stick to this. Cool. This entry does not do any harm. So this can stick in the hash map as well. Because since we booked it, we are returning to, hey, this is acceptable. Now I come to 5 and 15. I put it in my map. Let's say 5 and 15. And now I say, okay, plus 1 and minus 1. Cool. Now, whether this entry can stay in my hash map, whether is it allowed to book or not, let's see that. So iterate one by one. So when I'm iterating one by one, I'll be here, right, at this point and this. So these two value 1 plus 2. Oh, 3. Oh, this is greater than my MOB. Oh, okay. So this is not an acceptable value. This is causing some issue for me. So this cannot be taken in. Okay, so this cannot be taken in. I have to revert. I have to revert in my hash map. It cannot stay in my hash map because I am not taking it. So what you will do it, just do the opposite. Just do the minus minus for MP start and plus plus for MP end. So what will happen now? This comes out to be 0. This comes out to be 0 now, and this comes out to be 0. And one more better thing will be, if any index after doing this operation comes out to be 0, just remove it. Why to occupy memory? Just erase it from your hash map. You don't need unnecessary memory because you are doing a traversal one by one on these values that you are having. Why to keep extra unnecessary values, right? So this cannot be taken. 5 and 15, now we know. Cool. Now let's move to the next one. 5 and 10, can this be taken? So I do 5, there's nothing, and then 2, 10 is already there, just I'll decrement it minus 1. Okay, now can this be taken or not? Let's see. 1 minus 1, that's 0, no issues. 0 minus 1 equal to minus 1, no issues. Minus 1 minus 1 equal to minus 2, that is still not issue. Plus 1 to that, it's still not an issue. That will give you just minus 1, right? And minus 1 again will give you minus 2, that is still not an issue because none of that iteration we gave a higher value than the MOB. Okay, so that is how this algorithm works, on the basis of these sum of these values in the hash map. Okay, let's code it and things will be more clear if they're not clear by now. Okay, now let's code the solution. Firstly, we'll take our map, int and int, say map. Okay, and then our variable MOB. Okay, now let me initialize it over here. MOB equal to 2 in our case. Okay, 1 second. Extra code. Okay, now in our main function, booking, this will be called, and we will be provided start and end. So what we can do is, in our map that we took, right, we'll be having a start as plus plus. Okay, and we'll be having an end with minus minus. That's it. Now int current sum, let's say current sum is 0 for this booking. We'll say, hey, current sum will be 0. Okay, now let me iterate over this map. I'll say this will return me an int type of variable. Okay, and I say bookings. Okay, and map. Okay, now I just need to take current sum. Okay, so current sum plus equal to bookings dot second, since it's a pair, right? Now, just a computation. At every step, we were taking this for first value, whatever the map was there, we took the sum, but we were also comparing it with the MOB count. So, if current sum is greater than MOB count, this booking I cannot take. Okay, I just want to take this, so return false. Okay, and before returning false, what we also need to do is we also need to unset the value. So map of start in our case will be minus minus, and map of end will be plus plus, doing the opposite that we did over these lines, right? So it will be just the opposite of those. Cool. All right, and you can return false. To be more, space efficient, we can also do if map of, you know start now comes to 0, you know just simply erase this, erase the start value. Similarly, if map end comes to 0, map dot erase your stop pointer. Okay, if we have traversed the whole hash map and we didn't return false, we'll return true in that case. Just return true. Okay, so this function will return true to you. Let's see. Hmm, okay, stop. Oh, my bad. It will be end over here. Okay, so the test cases pass. Okay, let's submit it. Cool, it worked.